Right, so welcome to lecture 1. So we've just had lecture 0. This is the introduction to pandas. So last week I did with the team, we did introduction to Python. So this time will be introduction to pandas. This slide was originally done by Imran, who was the president last year. I think these are some very good slides. I spoke the other day. So it's going to be quite an in-depth introduction to what pandas is all about. And I've got some code ready in the workbook. We'll talk about them. I'll sometimes write my own code wherever necessary, but we're just going to follow through and see where we go. This is the structure so far. So we've already done lecture 0, then lecture 1. I'm taking all the lectures, and then I'll be lecture 2 next week sometime, lecture 3 and lecture 4. And after that, we'll start looking at projects. In terms of the project, I've already started looking to actually set up the projects. Adam over here is from the Investment Society, is joining me on my one. But we'll speak about that on a later date when things get settled down a bit. So in terms of GitHub, there is a GitHub for this. This was from last year. My notebooks and Imran's notebooks are all in there. I've put Imran's notebooks actually in the Google Drive under the last year's version. His one's much more in depth than mine. My notebook today only covers the code you're going to be seeing in the slides. But I thought it'd be nice to introduce Henry because he did a really good job. This is his instructions. I'm not sure how much of this is relevant. I'm not the best at GitHub, although I'm quickly figuring it out. I just didn't figure it out in time today, so I thought Google Drive will suffice for today, although from next week onwards I'll probably get the GitHub going. Files for today, as I mentioned, are all there on that Google Drive. I've just put the QR code in there. It's got the Excel files and also a comma separated file, CSV file, which you need to have in the same directory as your own files. I'll just show you what that means. So if I extract the files, it's got my notebook and my Excel and my other Excel as well all have to be in the same folder. I can't, for example, put this in the original 2023 folder because then the link will break and then therefore the files won't work. I have an hour and 45, so I know what time I need to keep. I'm going to be quite brisk, but try to keep you guys up to in beat as well. So start talking about pandas itself. So why is pandas useful? So pandas essentially is otherwise known as panel data, and it was designed by a few economists to help make data easy to manipulate and wrangle. So wrangling essentially means to actually be able to mess around with the data and get some numbers that you want. As you're doing this, you may find it more useful to actually install pandas on Python. I'm just going to do that quickly here for demonstration. So on Mac, you have Terminal. On Windows, you will have PowerShell. I hope it works. It does work on my one. So you will just have to put in something like this. That's because this computer doesn't have Python installed on it. But if you do it on your own personal computer with Python installed, the pip package should be there. It's just a package manager. It just takes code from other people who've written it and then installs it on your computer. And that's exactly what I mentioned. So it helps install other people's code on our computer for our own use. And this is just a little graphic that Imran put there to show what pandas is all about. It's just a couple of pandas trying to stand up from a data set and try and clean it. So that's exactly what I was talking about. In terms of what it does clean data. So it fixes errors in our data set. It does it no matter what the size is. Normally Excel has a limit. Pandas does not. It does wrangle data as well. So it helps us to manipulate the data for our own uses. It can also help us to munge data, which is actually adapt the data for downstream processes. So, for example, if we need it as part of our set of steps in our data series. We also use it to manipulate data, so to try and get key information out of it, especially if there's data arranged by time, so you can look into the past, and also to visualize data, so we sort of extract graphs from it and try and look and see what's going on, which is what I'll be covering as well. So. In terms of bringing code into our file, there's a couple of ways to do it. There's 3 different ways here, as you can see. Essentially, what we're doing from the previous session that I showed you is we're trying to take a class that someone else has written and we're trying to execute it in our file. The first way is to just simply do import pandas. It's the most logical and straightforward one. But every time you need to use something, you're going to have to start with pandas. Pandas word, that is in capital because my PowerPoint capitalizes every first letter, but it has to be case sensitive, so it has to be lowercase p. So if I'm using the series aspect of pandas, which you'll see in 2 or 3 slides, next slide rather, I need to have pandas.series. The other one is a bit simpler. You'll see this quite a bit, especially in your STEM studies, is you normally import it with a special alias. An alias is just a name or a nickname. So here I've imported it as PD, which just makes it easier to write, but I'm still using the same functionality. The most common thing that people tend to do is they tend to do from pandas import a specific thing. Now the thing is, if we're looking at it comparatively, the first one is the most straightforward, as I've mentioned. The second one just saves you typing, and the third one isn't recommended because if you have something else in your program that's also called series, there's going to be a clash, and one of them will win out. Normally, it's the one that's been used last, and if you've got any code that involves Panda series, it will crash. Rather, it won't work. So, with that in mind, we're going to discuss that in a brief moment in terms of the actual code. I'm going to talk a bit about pandas themselves. So, pandas essentially uses something called series. It's essentially just a column of data that is numbered starting from 0, because Python always numbers it from 0. The column itself has a header. I've given it the column is given here as name, and it's also got an index because we're indexing each row of data. Series, which is what this is referring to, is just a one-dimensional data structure that can store data. So it's one-dimensional in the sense that if you took all the names, Imran, Ahmed, Nicholas, and Julian, it all fits onto one line. It's one-dimensional. It only goes along the x-axis, if you want to think of it that way. An example would be, for example, if we're going to use a series, is to take one series, take another series, and add it together. Now, of course, I can't add Imran and 22, nor do the indexes from 0 to 3 add up. Essentially, what happens is that you would combine two series to form a table. This is now two-dimensional. So I've taken two columns and I've put them together. This is what we call a data frame. So it's a frame, just like a picture frame, but instead of having a picture, it has data inside it. And what you want, way that you can think about it is essentially it looks like a collection of series because I've taken two series and put them together. This is where we're going to start our exploration. So we're going to look at creating series and data frames. So we can use the stuff that we've learned previously in terms of lists, dictionaries, and tuples to create series and data frames. So we'll start with the simplest one, just taking a list to a series. So we have a list, and we're going to take it to a series, and it's as simple as the following. So I have coins, I have 4 different coins. Bitcoin, Ethereum, Solana, and Avalanche. They're just a list, and I've just defined it using the square brackets. Everything good? Yeah. And then all I've done is I've used pandas. I will show you. I've imported it as pd.series, and then just passed in an argument which is coins. And as a result, to show it more visually, I've taken the following one-dimensional list. You can see it's one-dimensional because it doesn't go down; it only goes to the right, and I've turned it into a series there. Each row is normally also referred to as a record. So Bitcoin is one record, Solana is another record, and so on and so forth. That becomes more useful when you look at time series later on. So with that in mind, I'm just going to quickly pop over to the code. It's going to be a lot less than me typing code because there's a lot of code, but I'll show you briefly how this all works. So what I've done is I've imported pandas as PD, and then you've just seen the code already here. So I've typed out coins equals Bitcoin, Ethereum, Solana, and Avalanche. Converted it to a series, and I've printed it. And if I run it on Colab, all that happens is I print it as you've seen there. And the data type is known as an object. I'll explore that later on, so don't worry about it. But as long as it works, it should be all okay. If you do have any problems, we've got some members of the Blockchain Society ready to help you out. So far, unless anybody's got any problems, I think we'll crack on back.
I'm struggling to run the app themselves. It wants me to select a panel source.
So we'll let the computer science student here figure that one out for you. So with that in mind, we'll look on to the next one. So now I'm going to take a list and turn it into a two-dimensional data frame. So we have a list here, and we're going to turn it into a data frame. Very simple, very straightforward. So we can do the same thing here. We just, instead of using pd.series, as you can see here, pd.series, instead I'm doing pd.dataframe. So I'm essentially creating a data frame. When I use the word df, that refers to data frame. It's a very common thing to do, especially with pandas. So essentially what I'm doing is I'm taking the following list and I'm converting it to a data frame. I know some of you are looking at this and thinking you've just seen the exact same thing. In the previous slide, I do agree. It's just a one-dimensional data frame, but this has the potential to be stretched to the right and stretched downwards, as you'll see in a moment. Now the column, I've given it, hasn't got a name, we've just given it 0, but it is indexed at 0, so if I choose the first column, say column 0, it will be that column that will be selected. And as you can see here, I've got the exact same thing, nothing major has changed. I've just used data frame instead of series. And when I press play, or when I do Control Enter on Jupyter Notebook, it does the exact same thing. Notice it hasn't said the data type, that's what D type was for, just because it's a data frame and it chooses to do that in the settings. Next one is to take use a data frame with column names. So if I just show that for you, so we take a list of lists and we use that to create a two-dimensional data frame. It's slightly more advanced in very early stages, so the code looks quite strange, but it essentially looks like that if you bother to arrange the rows in the appropriate manner. So it essentially looks like you've already got a table there, and that's exactly what it is. I've got a table here called, it should be coin info, but here I've named it as coins. And then all I've done is I've turned it into coins info underscore df for a data frame. And there we go, we've converted that list of lists, because that whole list has got 4 lists inside it, and turned it into a data frame. Everything so far so good. So if I just quickly roll over for that, that's essentially what we've got there. We've got a two-dimensional data frame already over here. So this is what we're doing right now, is just looking at how to process data and get it into the form that we want. Later on, we'll see how to manipulate it. So we're starting with data input, then mashing about with it, and then outputting it as appropriate. Next, there's other things as well. We can take a list of dictionaries. So we've just seen a list of lists. So you can see here, that's a list of lists. Now we're going to use a list of dictionaries, and we're going to convert it to a data frame. It's the same thing, but instead of using the square brackets for the lists, individual lists, we're using curly brackets for a dictionary. Now we don't need a columns parameter because the dictionary already had key values in it that we can use for the column name. So here we've got coin, price in USD, US dollars, and the rank itself. And then that will be able to transform itself into a data frame, as you can see right there. So you can see the column names over here, coin, price, USD, and rank, are all the keys of each of these individual dictionaries. So if I just show you that here and press play, that will be fairly self-sufficient and straightforward. That's all I've managed to achieve so far. Other things as well, if I wanted to try something cleaner, so I can have a dictionary of lists. So I just tried the list of dictionaries, but now I'm flipping it. So now I'm going to try a dictionary of lists and turn it into a data frame. So here what will happen is that each of the keys corresponds to the actual data in the column. So coin is going to come out as one column, so will the price of USD, and also the rank. You can see that here on the bottom right. So if I just press play for that as well, I think you're getting the hang of how this routine goes. It gives you the exact same answer. It's just a different way of arranging the data. The more we go into it, the more efficient you'll see how things get. There's a couple of others as well. I think this one is a dictionary of series that turns into a data frame. So here we've got 3 individual series on the top, coin, price, and rank. And all I've done is I've created a dictionary to say the coin column corresponds to the coin series, the price corresponds to the price series, the rank corresponds to the rank series. And all I'm asking the data frame to do is to put that all together into one nice package here, same as you've seen before. And this is even neater. So we'll start with something that most people will do, but this is the more neater way of doing it. There's also a few more which are quite cool. So I'll just press play on that. You can see here it's the exact same code. Started with 3 series, which is a better way of doing it. Putting the dictionary together, so saying that the key, the column name, the value is the column data, and then putting it together in a data frame, as you can see in the penultimate line before I print it. So that's essentially the second neatest way of doing it, as you can see in the output here. We can also use a tuple. So tuple, if you remember last week, was a list, but rather than using square brackets, we use rounded brackets, just like we do every day. And that is a list that you can't change. So we use that, for example, in the days of the week, Monday to Sunday, because you can't technically change the days of the week. So we take a list of tuples and we also convert that into a data frame. So what we do here So we've got two different lists, standard lists, Bitcoin and Bitcoin for the coins and the prices in USD. But what I'm doing here is I'm putting the tuples together. So I'm putting coins and prices in USD together, and then putting a round bracket around them. And then, as you can see, here I've got two lists. I zip them. So if you think of a natural zip for your jumper, what happens is that the 1 and the 5 get pushed together, the 2 and the 6 get pushed together, 3 and the 7 get pushed together, 4 and the 8 get pushed together, as you can see here on the far right. And then we take that data and then create that association between them. Hopefully that makes straightforward sense. Just might be quite new to you, but essentially that's the most efficient way, but less common. I normally use the dictionary method here in my own personal practice. Different ways. You don't have to remember all these ways. You can try different things, whatever seems most comfortable for you. And you can also try and change the code to add in the column names. So you use the column attribute that you saw earlier to include the column names here, as you can see. So sometimes we might also be interested in going from a data frame to a series. So rather than taking a whole two-dimensional table, I might want to just take one column out of that table. And I can do that simply in the same way that I was working with a dictionary in the previous week, where I've got a dictionary, and all I do is I pass in the key value. Here I do the same thing. I take the data frame name, and all I do is I pass in the column. So it's coin df for data frame. I'll repeat that, and I just want the coin column. So it seems quite logical that I'll just pass in the coin column name, and then what I get out of it is a series from it. So the name of that column is coin, and the data type is an object because it's a list. And a list is seen in the Pandas program as a object, and I'll just explore that later on in the presentation. But so far, I think that should be okay. So if I just play for that for you as well. So here I'm extracting the coin column from the coin data frame, and I'm just asking it as well what kind of data that is. So it's a series type data, as I've expressed just a few moments ago. And now that's pretty straightforward. I think that wasn't that sophisticated. It was just taking hard-coded data and converting it into a table. However, in the real world, you're not going to be using hard-coded data. You're going to be using data that continuously changes. In the same way that when you're doing an experiment, you're always taking in data that constantly updates. So how do we navigate that is a question that I shall answer right now. First way is to use comma-separated values. So that's a CSV. A CSV can be used to produce a data frame. So a CSV, as I just mentioned, is a comma-separated file. So each column is separated by a comma. Here is one there. So the column names are on the top. Date, the different coin types, Ethereum, Ronin, and Solana, and each individual line then corresponds to that column. So the first field is the date, separated by a comma, and then we've got Ethereum here that corresponds to that, Ronin, and then Solana. Of course, they're not aligned when you actually look at the CSV, but they're separated by commas, so you can match the data to the column that it participates in. Pandas is quite neat rather, because it has a specific method or a function called read_CSV. So read a comma-separated file that allows a CSV file to be turned into a data frame. It's as simple as this. I provide the file path, so in the folder that I'm in, I'll just give it the name. It's relative because it's relative to the file that I'm located in. So if I'm located in C drive documents, then that's where it's going to start looking from. So it's relative to that. And then all I'm asking you to do is to create an NFT data frame on line 2. And I'm saying, can you read this CSV file for me? And then we'll print it out for me. Just to show that here, I've got the same idea. So my notebook lives here, and I've got these two files living in the same directory. So when I was checking to see if this would work, to see whether everything was lining up. So when I press play for this, what happens is that the file is processed and all of the data is shown as shown here. In fact, if I can do so, since I'm already charting through this, I'm just going to open this in the other traditional. I'll see if it opens in Excel. Excel is the commonly used source of information, also the visualization of information. So it's the same file here, except I'm doing it in Pandas. So if I compare the two just momentarily, so I've got all the column type that in, all the column data, and same columns here, and the two-dimensional data as well. Just to mention as well, for your information, this you might see it splitting over two lines. The only reason is because this window isn't big enough. So when it ends at Solana, it's just wrapping down to the bottom. So the next column will be wax, and it goes in a zigzag fashion. So it's not the file isn't broken, but it's just like that. It tells me I've got 250 rows and 12 columns, which is very neat for my own interest. So if I just rotate back to that, so that's essentially how I process a CSV file. We can also do other stuff with it. So as you saw in this file here, we've got headers as well. But these headers could also actually be used as the column name for our table. So if I just briefly show you here, these column names can actually be processed into a data frame. So if I've got the same file, we notice that the column names are on the first row of that data of that file. So we just say it's on row 0, i.e. the first row. So we can try and use the header parameter to actually specify that these are the column names. And all I've done here is I've just simply added header equals 0 to specify these are the header names. So when I process my, as you can see, with header equals 0. So when I process my data frame, it doesn't look the same on Colab, but if you actually try and do it for Notebook, you will see hopefully a slight distinction. Whereas now I can actually use these column names to actually manipulate them individually and take them out one by one. I wouldn't be able to do that, as far as I'm aware, without passing in the header. Also, it makes it more safe if I actually include the header than if I don't. So it's all very simple so far. It does also allow you, the read CSV function, to use a column as your index. What I mean by this is if you look over here, all my data so far, or if I show you more easily, Alt-H-O-I. So all the data so far is numbered from 0 to 249. But in Excel, you can see the data is arranged by date. I would like to use that date column as my index. So if I'm going down the data, I want to look at 2017. I want to go through 2017 instead of from 0 to 11, for example, as you would see in this Panda's example. What I can do is I can specify that I want the date column to be the column by which I index my data. All I would then do is just add another little parameter on the end saying index underscore column is equal to the date column. And what that will then do is it will transform that data frame to now on the far left, as you can see, it now arranges everything by date instead of just giving it a number from 0 to 250 or so. All I've done is, if I show you the difference, I'm just going to copy this just to show you the difference there. What I'm doing is index underscore column is now the difference. So that's the only thing I've added here. One thing as well, if you want to comment something, I believe it's Control and then backwards forward slash or the question mark. There you go. So it won't, that line won't run. And as you can see here on the far left, instead of using 0 to 249, I've got the dates. So now I can use those dates to work for the data. So far, so good. Anything else? It also allows you to specify which columns that you want to extract. That is true. So instead of, for example, instead of importing all the data, so just to show that, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different columns, in case you're kind of confused where that comes from. So I've got 11 different columns. I might not want all 11 columns. In fact, if I just look at the little shortcut, so I have 11 different columns. I might just want 4 of those for now. So what I can do is I can specify which columns I want to use, hence use columns as another argument. By the way, line 2 isn't actually written over 2 lines, just because I couldn't fit it in. So I'm just saying that use columns. I want to use the date column, the Ethereum column, the Solana column, and the Avalanche column, and then print it for me. So where are we? So if I just go down, it's the same thing. Instead, I've just shrunk that from 11 columns, as you can see here, to 3 columns there. To make things a bit easier for me to work with. And I'm just looking at these 3 coins. And if you're interested, I think the slides do have, there are slides, I believe I put them up there. It's in small text, I admit, but there are, if you type in the function name, so I'll show you rather, for completion, so Control T, pandas read CSV. The documentation shows all these different types of parameters that I can include. There are many, I'm just using a few of them, but as you can understand a few. So this is compulsory because you have to put a file in, but then and then star just means whatever else you want, and then all these ones are what we call keyword arguments. I'll discuss that later, but there's a lot of different functionality that I can do. So for example, I can remove some white space, I can set how the decimals should work. Do I want to skip the footer, so on and so forth, delimiter, etc., etc. That's all for your own interest. So just to summarize that again, all I'm doing is I'm taking just 4 of those 11 columns to turn into a data frame. Although in this example I haven't shown all 11 columns, I've just shown a sample of them. Now, I've also got Excel files. I think I've just already shown you how Excel is used, but I'll load it up on here as well. So if I do open, browse, downloads, lecture 1, I think it's this one. Yep, so I've got 2 different worksheets in a workbook. I'll just describe that in a minute because some of you will use Excel quite frequently. I can take Excel and turn that into a data frame as well. Pandas does have a read Excel function that works just like the read CSVs you just saw. So this is exactly the file that you just saw. I've just blown it up just so you can see it. The file itself is otherwise known as a workbook. If you think about book and each of the individual sheets, the actual file is known as a workbook. That's the old term, because back in the day, that's how they used to do a lot of their analytics. They used to have a massive book and then split it up into individual grids. The workbook is then comprised of worksheets, which we sometimes call worksheets. This workbook has 2 worksheets, as you can see on the bottom. And just for your information, worksheets and spreadsheets mean the same thing. So if you're researching Excel sometime later, that's what this refers to. So we do have a read Excel function, and that's how we do it. It's the same way as you just saw with the CSV file, but instead I'm just using a Excel spreadsheet. So here, this little dot here means stay in the same location as the notebook. So it just means one dot just means stay where I am, and then run the NFT data spreadsheet. And all I want you to do is to convert it into a data frame. So read the Excel file. Here's where the Excel file lives, and this is the worksheet that I want to use. I want to use NFT transactions, and this will produce an identical data frame to what you've seen before. So if I just show you that here, where are we? Follow along. It's the exact same. So we've got, so NFC transaction, we've got NBA, CryptoPunks, Hashmark. I mean, I don't know what any of this is. Well, no, some of it is, but you get the gist of it. And it's transformed that same thing. Notice as well, I'm just going to point this out for you. For example, with NBA, you haven't got any data here. It's all just empty. We do take this into consideration. Pandas fills it in because it doesn't just leave it blank. It puts something called not a number, NaN. I'll discuss that later on, but I just wanted you to know that for now, because Pandas is very flexible in terms of making sure that it's aware of how much data there is or how much data there isn't. If you had multiple worksheets, so we just had 2 spreadsheets and I want to work with them both at the same time, it's very straightforward. All I do is I just create a list of 2 sheets and I just pass that in. If I just compare that for you, sheets only has 1, so I've just got 1 thing to name. But if I've got 2 or more things to name, I just put them in the list and I pass them in. It's very simple. It's very straightforward. And this will produce a dictionary of data frames, and then each key of the dictionary will be the sheet name and the corresponding value will be a data frame. Probably easier if I just showed you that instead of just claiming it to be the case. So you've got a dictionary here. This is one dictionary, and then I can't find where the other one is, but you've got exactly 2 different worksheets here, all compiled together. You can see there's one worksheet, NFT transactions, and the other one is NFT marketplaces, and they're both imported at the same time. You can see the number of rows, the number of columns, etc., etc. You can read many different types of files into Pandas: CSV, Excel, SQL, JSON, which you'll see in a moment. but anything that you can think of, Pandas will probably have covered it for you. We've just looked at data that is on a hard drive on our computer, but we can also look at data that is online. So we're downloading it from the internet. We're going to actually just expand on this. We're going to need some more stuff, more programs to help us do that from the online data sources. So we've got HTML. HTML is basically what websites are written in, hypertext markup language. And we're going to download that and we're going to convert it into a data frame. The first thing I need to do is I need to do pip install requests. You need to do that on your own laptop, and that essentially gets Python to install the request package, which is just a bunch of code that someone's written to help you download things from the internet. There was going to be, just to forward that, then you'd import request and JSON. There was in the previous slides, there was something called pip install JSON. That's not actually something because JSON is already installed on your computer. So all I do, very simply, I download them, then I just import them. That's step 1 and step 2. To actually run the code, it's relatively straightforward. I've created a variable called URL, and all I've done is I've given it a website, and then I've just said, can you go to this URL, get the data, and use it, make a data frame out of it. So request.get, which is this little thing here, will send, this is more computer science terminology, but I'll just mention it. It sends a request, so it sends a request to another computer that has the website. So we're the client. If you think about client as in a more professional sense, we request a website to give us some information. The website might be on a computer or the server, and the computer responds back saying, sure, I'll give you the website, and it responds back with that website. And this is done using the HTTP protocol. It's just basically a system that allows computers to talk to one another. So if I show you that here as well. So this is, first of all, I have to import request and import JSON. And then all I do, as you saw in the code, I get this sort of output. You might notice this output doesn't look very easy to read. This is because it's designed for computers and not you. Computers are not humans, they're solid state machines. So to make our life a bit simpler, we can convert that very messy HTML response to something that might be more human readable. And this is where JSON comes in. JSON is JavaScript object notation. If you heard about JavaScript, this is sort of where it's coming from. And it's basically a way of converting very messy data from HTML or from websites just for us to read. And they're lightweight and they're human readable. And they're designed to look like dictionaries that we just saw in Python. And all I do is I just strap on a little bit at the end, .json with 2 brackets to show that it's a method, and then I just print it there. So if I just show you that again, so I compare, copy this line, and what you can see is all I've done is I've just included another JSON there. I just command that with Control / and then run it. I'm hoping there's an Amazon code at some point, but it's the exact same thing here. So you essentially can read this now a lot easier into your data file, and then that's used to actually get the data frame to look more presentable. It's, however, a big data set. I think if we just have a look at this for a second, it's got 62 rows. We might not be interested in all 62 rows, especially if we're looking at data that's very recent. You might just want to look at the last 5 things that have happened, or the last 10 things that have happened. How do we do that? How do I might, for example, just want to get the last 10 stock prices and just calculate something out of that? Still use HTML, but what I do is I just use a special method in Pandas, which is called the .tail method. Essentially, if you think of an animal, you've got a head and a tail. The tail's at the back. Same in data, you've got the head, which is the top, the tail is at the bottom of the data set. So we've got the same URL, exactly the same thing. And all I've done is I've gone in the print function, I've said, because the data frame is an object and it has its own tail method, I said, can you just return for me the last 5 results? That's what it would technically do in a more visual sense. So I've got 11, if you imagine I have 11 rows here, it will just extract the last 5 rows. To show that here, I'm just doing the exact same thing here. All I've done is I've passed 5 with the tail, and there. It's done it on 2 different spreadsheets, by the way, or rather on the same spreadsheet over 8 different columns. But you can see we've only got 57 to 61, so it's the last 5 data entries at the tail end of the data. Indexing. Right, and this is slightly different now. So we've been able to import data, which is relatively straightforward. I might try and get stuck in now at this point if I'm able to. We've done indexing from lists and strings. You definitely may have experienced that in your own personal studies. We can also do that with data frames. Indexing allows us to select particular rows and columns. We've just seen how to do that with a column right at the very start, where I put in a column name and I got all the names out. The same process here. If we look at the CSV file, we've got one example here, which is to use the lock lock method here. Lock means locate. So we essentially will extract the row. This time we're looking at rows, not columns. We're looking at rows, and we're looking at the row that is labeled 0. So it's the 0th index. So if I show you that here, now I'll see if this works actually, because I haven't done this in a while. I'm going to comment this out. I'm going to do print nft dt. See what that says. That's df rather, because dt is mathematical. So I've got this data frame here. Of course, it would go all the way to the right if there was space. But if I now do, I'm hoping this worked. If I want to get the 0th row, I'd expect the 0th row here. All I can do is I just do .locate for me, please, the 0th row, and I use square brackets. It's a bit unusual because this one has square brackets as its operator, and the other methods have rounded brackets. That's just a trivial aspect. And what it does, actually, if I just show you this, so can I put in a new cell? Yes, I can. If I do the print, now some of you might be thinking that this looks like a table. What it's done is it's taken each of the columns along the rows, and rather like so here. And what it's done is just rearranged it into in a sort of format that's a lot easier to see. So, for example, Ethereum is indeed equal to 1.97. It's in scientific format. That's something you just we were going to show you how to convert scientific format into raw numbers. Unfortunately, that's a bit beyond your scope at the moment. But essentially, each of the column names now become labels down the column, and then you get the data here. So each of the rows essentially reformatted into this easier to understand way of doing things. So I'll just delete that, hopefully. Good. That's how I extract a row. I can also extract multiple rows at one time by just passing in a list of different numbers. Hopefully, I think I've got that. So if I just comment that out, I'll comment this one out first, because here. With the first line here, the dot index, it basically just says what row is this one on. What are the labels of this index? So as you can see, it's got Ethereum, it's got date, Ethereum, Ronin, Flow, Solana, Wax, so on and so forth. Just asks basically what are the labels of each of the rows here. And if I just comment that one instead of uncomment this one to run it, I can now pass multiple data sets. So if it's one row, it comes out like that. If it's multiple rows, it just comes out in the same way as before, but just a bit more smaller. We can also set indexes to the column that we want. So maybe you might want to consider, again, as you saw, we might want to set the index to the date. So all I would do is I would do the read CSV as usual, and I'll just set the index to the date. I think we just discussed this a few moments ago, but it's just for repetition because this is essential. And this is a bit slightly better formatted at this point, because now all of my data sets, all of my records of data are now arranged by date. So 2017 all the way through to 2022. Same thing as before. So we take the data in, read it, set the index, and then view it. And that's a nice way of doing things. Actually, to show you this, if you do print, that's formatting is slightly lost, and it's printed out like that. Whereas if you don't do print, Colab and the other services will actually format it to you a lot nicer in a two-dimensional table. So that's, if I just show you like that. try and do it for now. But yeah, so generally we'll just format it like that in the table. We can actually provide dates now instead of row numbers. So if I want to provide 3 different dates that I want to look at, just show you that here. So now I can actually look at 3 individual dates instead of instead of 4 different rows that I've numbered 0, 1, 2, 3. I want to look at 3 different dates. Also, I might be interested as well in resetting the index. I've just done it here for the purposes of this notebook. But, when I reset the index, I go back to the 0 to 250 numbered notation. And I might have to just run all those cells again in the meantime from the top. So that helps us to reset our index. So there are also other forms of doing things. So we also might want to look at something else called iloc. Now, iloc is integer location, so it extracts. It is used when the index does not correspond to its integer position. So, for example, well, that's incorrect, but it would choose the rows that are corresponding to 0 to 3 if I've actually numbered the rows in my own way. I can also extract the rows and columns at the same time. So the first one is the rows, the second one is the columns. And also remember that Python has 0-based indexing, so that when we're slicing, the 3 doesn't actually get counted, so it's 0 to 2, 1. It's not 1 to 4, it's 1 to 3. I'm just going to show you this because I actually have to update this one just before you guys are coming in. There's a difference between iloc and loc, integer location and location. If you look at this, I've actually numbered my rows, hard-coded them, so they go to 2, 3, and 4, and 1. It might be the ranking of these coins. So if I choose iloc 1, it would return avalanche because avalanche is given the number 1. However, locate 1 would actually give me this second row here because that's the order of the table. So one of them actually looks at the number that's been given to the row. That's if I've hard-coded it like so. And the other one is the location in the table. So if it was loc 0, for example, this would give me Bitcoin. iloc 0, well, it wouldn't print here, but if 0 was, for example, Solana, it would give me Solana instead if I hard-coded it like so. So as I mentioned, the row with the index number 1, as you see here, corresponds to Avalanche, and the second row in the table corresponds to Ethereum. The index relates to the numerical value that I've hard-coded in each row, and the index in loc corresponds to the orders in the table, and it's the same way you think about the strings that you saw in lecture 0. I think I might have showed this might have got some traction here. In this situation, the rows have the same numbers because they're all numbered from 0 to 250. So this is kind of a crap example. This example is slightly better, but I thought I'd just show you anyway. And this is the same example as just taking in 0, 1 at the first, second, and third row. So now they're numbered 1, 2, 3, and also the first column, the second, third, and fourth column because Panda's Python numbers it from 0. So there normally would be another column, but it's not here. If I want to extract the date column, I think I don't know if that's actually part of it. So as you just saw, same thing as you just saw right at the very start. I just tell Python the data frame name, and I just provide it the column name. I can have the if you try and use double brackets, I'll leave you to see what happens there. You might see a change in output. Actually, let's see what happens. Hopefully it works. It doesn't. I might have to get back to you. I'll have to fix that at some point. I have to run all this code again because this notebook is quite unstable. You can also access the columns by making use of the columns attribute. So if I want to extract multiple columns, I can just do something like so. And also, if I want to look at the specific columns, what will happen is I get this sort of output where it provides me a specific output of the index object. So it has all the column names and then it tells me what kind of data that is. So, you might also require the need to, so as you saw here, rather, just before I rush away, we've got the data frame, and I've asked it, can you just give me the date and 3 different coins that I'm looking at, and it's provided me with that information. I've just realised as well that it's run all the code already. Anyway, and if I've asked it just to print me the column names, then all I do is nft df full stop column. Do you want to take a break, by the way, because it's getting quite hot?
Sure.
I'm not sure. I think I can finish by 8 o'clock, but I'm not sure there's any. Is there any aircon in this department? I know the maths department isn't very good at being a maths department. But...
Do you want to give it 5 minutes?
Yeah, do you want 5 minutes just to get some fresh air? Because I'm boiling as well. I'm not going to be able to focus.
Yeah, smoking break.
We'll resume in a couple of minutes. I just need some air. I'm wondering if I'm going a bit too quickly, but I'm putting out time. I was balancing the time as well. I'm quite insistent on my hours. Not because I don't, not because I want to get out. I just need to keep everyone else. Not fine. You get a pizza. So far, this is quite straightforward. Relatively, but it's the way I explain it, and everything that I show has a logical process. It's not like I just say it. It just does that. There's a reason why, for example, if you want the column names, you might like one thing I've realised was having the house, I know exactly what that show up. So it's like, I know what's going to
if we get the CAGB City Guilds 200, that's got the 2 screens, which are like...
Yeah, it's like easier. I'm just doing this anyway for backup, so I don't know what
It's really straight now.
Yeah, no, I like it.
Pizza will be in there.
I'm already halfway through.
I'll make sure I put a pizza in front of you.
But no, otherwise, I'm pretty happy with that. It's the thing is, I can't write all this code out. I repeat myself every time. But sometimes I get stuck into the code. The thing is, when you understand it, it's a lot easier. All you have to do is just type it. I mean, it's not like Python where I can type in 2 words.
Yeah.
But I do explain it.
No, yeah, it's too much to type in everything.
Then you'd be here all day going, oh, no.
Yeah, exactly. That's not me. Like most things I learn when it comes to language, just like now, it's just too much going on now. It's just going yeah, as long as you explain the important parts, that's what they care about. It's good numbers as well. How was it compared to last year?
A lot more this year, I guess. I guess it's a project for my life.
Could be that.
How you finding it so far?
We've been looking at it.
I was just kind of, I was invited as a guest. I think it's just quickly, it's just so like, initially it's a matter of
You also see
So this
works, yeah.
Oh, that's there. No, that's
yeah,
Do you use
Where's going to be? It's a bit close, isn't it? Okay.
good, I guess.
Oh.
I think I should start writing some code instead of.
Maybe,
I feel like
we got this grouped in a pod for this reason.
You know what would be good? I think a bit more like question, like interaction. Like ask them like, you know, what should I? What if I wrote this? What would happen next? Or something, or what does this do? Is it on there?
I'm trying to think how to fit that in because
It's always good because it gets people thinking about, like, and then that helps you remember.
So we have this area.
See how the camera looks.
oh, that's fine. They're looking at the screen. Not this.
Yeah, it's true.
No,
What do you do?
oh shit, sorry. I used to work in a family office, but I didn't enjoy it. So,
you doing like finance? Or?
I probably will go back to it, yeah. I worked in finance for a bit.
Do you not enjoy it?
Right. Oh yes, right. Go right to the end of the corridor. Straight, yeah, straight. Just walk in a straight line. There'll be one in front of you. Right.
Oh, guys, I know about that.
I know it was so much.
Right, of course, settle down, please. Sorry, are you Imperial as well? Are you part of Imperial? Are you part of Imperial? Are you a part of Imperial? I'm just curious.
Am I?
Imperial.
No.
Oh, right.
I'm a London.
Okay. Right. We just carry. So, pretty much. I would say that I orchestrated the break because I got very hot. It wasn't actually the case. It was because I contemplated starting to do some of the coding myself by hand. Since I realized that the suggestion I got given to just run through the code last year was a bit pathetic. Although I do apologize for the state of this stupid department who can't seem to install any aircon, but this is the maths department and they're quite mentally stupid. So you can deal with that in your own time. They should probably get cut out of the video as well, so I don't get into trouble. But it is true, they are quite mental and stupid. Anyway, without any further ado, I think we'll crack on now. So what I will do to settle things, I guess, is I will have both notebooks open. I'll type them out and then I'll scroll down and see whether what I've typed out matches with what I wrote before I got here. So where were we earlier? So we'll go from here. NFT.data frame. So I'll pick the date. So I want the date column to come up. Rather not the column, not date column. Rather, I might want the Ethereum column to show up. That's all I have to do. It's as simple as that. Let's see where we are in terms of the presentation. I might want to also ask what kind of column, what are we? What kind of columns data frame. I keep on doing DT because that's a mathematical thing. I might want to ask the data frame, what columns do you have? And it will say, this is all the columns I have, but it doesn't present it to me very nicely. I might want to make that a bit easier for myself. All I have to do is I have to do to list. Can I convert this output into a list? That's nice, easy to read, very straightforward, very simple. Now I'm starting to realize why I should have started typing from the beginning, so I do apologize. But now I'll compensate for that for the foreseeable future. So this is what I've got. I've got the data frame. I convert it to a column and then I say, can you give it to me as a list? It takes this output and transforms it into a nice, easy output for me to read. I mentioned this earlier, that when it says D-type object, essentially what happens is the lists in computers are actually much more complicated than they look. What that happens is that lists are saved in the computer, but in different areas of the computer, and they're all brought together because what we have essentially is that the computer knows where each part of the list is. It points to it using something called pointers, and that's quite a C++ sort of thing. I'll see if this link opens, hopefully, if I can just copy it, or it will open on. There we go. This is the one I've extracted it from. So this is how a list sort of works. So what happens is that each of the lists has a specific address, and this address says, well, if you take this path down this arrow, this is where you find ABC, this is where you find XY, and then this is where 1, 2, 3, 4 is, and you've got two arrows pointing to the same thing. It is also the same way that Pandas works, but because Pandas can't really elaborate on how the list was all structured, it just simply prefers to say that it's an object, and it leaves it out of that. It doesn't want to overcomplicate things, but it uses its own object type, ND array, to store these arrows in order to put the whole list together when it's asked to do so. This is where it gets slightly more interesting for me, at least, because this is where we actually deal with indexing stuff from a table that's very, very big. So the way we extract data from a table is to actually work with Booleans, and Booleans, you might remember, are true or false values. What we do is we essentially create a mask. The way we do this mask is by essentially first putting in an inequality. And from the lesson last week, I remember telling you that if you have an inequality, it will evaluate to either true or false. Now, to make that a bit easier, I'm going to just push that down a bit. I'm going to see if I've got it here. Yeah, so first I've got to do this. So I've got to set my index, or rather I have set my index already. That's what the message is. Yeah, I have set my index, so that's not a problem. If you look at, for example, this one number here, it's 197. Even better if I show you here. I've got this number here, it's 197. It's, if I want to look at all the trade volumes, trade volume is volume times price. That's, so if I say, is that less than or greater than 10,000? It's less than 10,000. So what's going to happen? This cell will evaluate to false. False, false, true, true, so on and so forth. I can actually do this in one line in Python. All I have to do is I have to do NFT underscore df greater than 10,000, and what will happen, hopefully it does happen, starts to evaluate that for each of these cells, false, 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 true, 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 wherever it's appropriate. What will then happen is that will be used as a mask. If you've done Photoshop, you'll be aware of clipping mask. Essentially what happens is where it's true, that number will be kept. Where it's false, that number will be deleted. So, or I'll say deleted, it won't exist, or it'll be not shown. So this number will be deleted, this number will be deleted, so will this one, but not that one. That one will be preserved because it is true. Where am I? Here we are. So I've got this mask here, and it goes all the way around for 250 rows and 11 columns. So that's 2,750 cells, some thereabouts. I use this now to index my data frame. I'm going to do a new one. I'm going to minimize this. NFT low underscore volume. So tell me where, or rather actually high volume. Tell me where the volume is higher. A high volume. I said low because I was doing a previous exercise. NFT DT, NFT DT, DT DF again. I keep on doing this. Is greater than 10,000. Sometimes print, but it doesn't. Print. And where it is true, the value has been preserved. Where it's not true, that value has been deleted. NaN, not a number, doesn't exist. And that's essentially how I filter tables, as you can see here. That's how I filter a whole data set. So whatever is actually true gets kept. Whoever isn't true gets deleted. So essentially it says that Ethereum on this day in 2017 was not above 10,000 in trade volume. And that's a very straightforward way of doing it. In the interest of time, I'll sometimes mix and match between how to switch things. There are other ways of doing it as well. So if I just flip over back to the presentation, I believe. So that's essentially what I was doing there. It would give me a true and false mask. That's it. So if we can actually say more than 10,000, this is how we would do it. So these cells that output a result are the ones that were true. Some records will return not a number because they were false. Those are the ones that have less than 10,000, and we'll look at how to delete them in the future. Yes.
How would you, for example, count like the number of true that you have in the whole thing, in the whole table?
That's a good question. I haven't covered that. There would be a couple of ways. One way would be to loop through the whole table. And for every time you have a true value, you just increment a counter. So start from 0. If true, add 1. That's the very long way of doing it. There are probably, I haven't researched this myself because I haven't used it yet. There is 99% chance that there is going to be a method that actually evaluates that. So for example, count something. It might be in my presentation, but there are different ways. The simplest and the most long ways to do what I've just said. There will probably be other ways. That's why we read the documentation. Other ways, as you'll see later on, is to just type on Stack Overflow how to count number of true values. There'll probably be a solution. Off the top of my head, I don't know, but there are ways that I think about it as a programmer myself. Is that good enough? Fantastic. Other ways of doing it is to look at the is-in function, or ISIN, as some people say. So what we will do here is to start with we'll look the other way around, see which ones don't go above 10,000. So we'll look at all the numbers between, well, rather, this will do the other opposite way first. I can look at all the numbers between 0 and 10,001, because remember, 10,001 isn't counted, so we always go for one less. And then what happens here, it's a bit interesting, is that whatever was this little thing here is a not operator. So if I do the math, it's in maths actually, not true equals false, not false equals true. It just flips the true and false. Essentially, it will just invert the whole thing. So if I did, hopefully this will work. I haven't actually done this for this presentation. Where's the tilde? I can find the tilde. Hopefully. It doesn't work. I have to figure that out at some point. Oh, tilde and then brackets, hopefully. What we would hopefully do is flip. There we go. It flips the table the other way around, so it's everything less than 10,000. This is actually a quicker way than the one that Imran suggested. But Imran suggested to do this sort of thing as type and is in volume. Mine is just a bit cooler. This is another way of also getting a for loop. We didn't discuss this last week, but this is why I like to do this. In the interest of time, I'll probably start speeding up at some point. So if you remember for I in range 10, print I, simple as that. I can also then create a list of that. My list equals something, and then I just switch that. Instead of saying that, I'll do my list dot append I, and then at the end print my list. Makes sense? I've just added 9 numbers. This is quite long and it takes a lot of lines. The quicker way is to do something called a comprehension. Comprehension means, well, comprehension, one word, that is to read something. The other definition of it is to make things quick. And all I have to do is I have to put 2 square brackets and then just put the for loop inside that. I for I in range 0 to 10,001. So the exact same thing, but even quicker. I for I, well, in range 0, 10,001. Well, rather 10 if I was doing my one. Same thing there. It's all very short. It's a lot quicker actually, because it doesn't have to go through the loop all the time and then append it. It's just a much faster way of doing it if I was actually measuring the time. You can also add conditions. So if I want all the even numbers, all I have to do is if I take the remainder of it when divided by 2 is equal to 0, gives me the even numbers. It's even quicker than the append way because I don't have to append as a separate operation. It will take care of that for me. It's a much more optimized or faster solution of doing things. But I just wanted to show that just to get a bit of an idea where Python can go. So this was Imran's solution. So if he does as type, this solution I don't really like, but essentially what he says that he converts all the data frame values to integers. So it's called casting, and then he looks at the numbers that are less than 10,000. So if he was looking for more than 10,000 rather, and then he flips the falses to trues as I showed you. My one was a bit quicker, and then he uses that true and false mask to create his own data frame. This is how he does it. I do it a much more shorter way. Both ways are fine, whatever works for you. Now, where are we? Can we extend this? Can we extend this further to filter specific columns? Yes. So if I wanted to look for the specific coin avalanche and see when it was greater than 10,000, I can actually do that. Hopefully that's been covered here. So these are all the different ways that you can do that. That was Imran's solution. So if I looked at, so the way this is structured, NFTDF avalanche, you are aware that takes the entire column. I don't want the entire column. I only want moments when it's greater than 10,000. So let's try 100,000 because you can see there's one that's 20,000 and one that's 130,000. Smash that through and then use this whole mask to index my data frame. And it will only give me a collection of numbers here. If I print it rather, that might be a bit more palatable. So you see it only indexes those rows as such. And then what you can also do is I can do more than one condition. So if I want to do less, if Avalanche was when it was less than 1,000, and then when Ethereum was less than 10 million, I just have to use the AND operator as such, and then I can just chain more and more conditions as we go on. Slicing as well. Where is slicing? So in terms of actually splitting up the data, so that's what I call slicing. If I do the following example, this you might remember just returns every third row from the table. This one will return the data frame in reverse order from the bottom. So if I take my original data and then do a -1, you can see the 2022, the last date comes on the top and the very first record goes to the bottom. And this is the exact same as you did in strings. I think the code is here for me. So that's when you chain different ones together. Here, so the one I've printed, so this is printed 3 different types. So this is only printed, where are we? There we are. This is printed the first 3 records. This is printed all the records in reverse order, so the years on top. And this is also done reverse order, but print every other second row. It's all very good, straightforward so far, but now we might look at combining data frames. So combining data frames is essentially the idea of taking two different tables and then hooking them up together. So we did two different series, but now we're doing two different tables. If we look at this example here, see if I can actually do this. I'm just checking if there's any redundant code. Okay, good. I'll try it here. If I want to separate this code df1, so I'm taking a split. I'm splitting this up. So I'm taking the first 10 rows. And have to, and because this is Colab and Jupyter Notebook, I have to show you this. I have to mention it by name. It takes the first 10 rows. You can then probably guess that if I do second one, it will take the next 10 rows. So that's the next 10 rows. All I'm doing in this situation is now I'm going to try and concatenate them. Concatenate means to put two things together. So all I have to do is nft concatenated data frame is ask pandas to concatenate the list of data frames nft df1. And this auto-filled. Another thing as well, I think hopefully I can do this. I can also use the tab to fill in. Autofill. It doesn't work now, but yeah, when it autofills, and then print nft concat. What it's done here is it's merged these two tables together back to the 20 rows they joined together. So that's the concatenation. So visually, take two different tables and then merge them together. We can also do this side by side. So rather than combining all the rows, so 10 rows and then 10 rows and add them together, we can also combine columns. So take these two columns, and all I have to do is I have to say axis. I think this slide has the axis bit. It will be in the few slides time. Axis 0 means the rows, so go along the rows. Axis 1 means down the columns, or use the columns instead. You will see not a number because some of the rows don't have the indexes. So if you see not a number, it means that cell didn't exist beforehand. Just to show you that here as well. So what Imran has done is he's created two different series. So 0 to 5, 0 to 5. One of them's got price, one of them's got rank. And all he's done is joined them together. He's fused them together to get a new table. That's another way of creating a data frame as well, merging them together. There is a nuance as well that I think he's wanted you to know. So this is what we've done here. Take this table, take that table. Notice that there is no number 5 for Dogecoin. So what will happen is if we join them using a left join. So we've got this df price, and then we've got df rank. And what will happen is if we merge them together, how are we merging them? We're merging them on the leftmost column, on the index rather, on the coin column. There are different parameters, so you can do left, right, outer, inner, cross. The default is inner, and you choose the column that you want to mix it on. So you've got Bitcoin and Bitcoin, Ethereum, Ethereum. So it'll overlap there, and then it will choose, and then it will put these columns together as well in the corresponding fashion. But notice that because Dogecoin did not have a record in rank, it gives not a number. Not a number is now suddenly becoming clear that it's used in the absence of data. Hopefully that's here as you saw here. So what we've done here in Dogecoin, we've actually included the number 6, but if I just try and delete that, oh, for God's sake. So it's because, yeah, it won't let me do it if I do it from scratch, but it will happen if you import data. It will return not a number. I'm just checking to see if everything is working as such. So we also have situations, for example, to choose on which index to mix on. So we have, for example, these 5 numbers and these 4 numbers. What can happen sometimes if you put both of them together, which is very rare, Imran wants to mention this, is that you essentially get both columns together and it will show which one was which. So X is the first one, Y is the second one. So X corresponds to DF price, Y corresponds to DF rank. Not sure why it's entirely relevant, but there probably is a purpose to it. And then it distinguishes that with the X and the Y. There are different types of joins. So this is more familiar if you've done SQL. You've got inner join, which takes the overlap, and if there's not if it doesn't overlap, then there's not a number. Left outer join, it just takes all the left values, and if there's anything in B, right outer join is the opposite. Full outer join is if it takes the union, so it takes all of them together. And A and B, A times B is a Cartesian cross join. Doesn't seem very familiar to some of you, but if you think about a 2D graph, you've got an x-axis, 0 to infinity, 0 to infinity for the y-axis, and you get the coordinates 0, 0 in brackets. That's a Cartesian cross join because you're taking two numbers, 0 and 0. Well, 0 and 3, they meet together at 0 and 3, and you write that down as a result. That's a Cartesian cross join. Am I right? You are a math student, so you are aware of that. And this is an exercise that he wants you to do, and he's also left that in the notebook for you guys to try. That's all there is about doing that sort of stuff. I'm sure that's very entertaining, but anyhow, that's not particularly of my interest. So now we're going to do some multiplication involving data sets. Now we're going to start manipulating data sets. So in crypto, trading volume is slightly different. When you're doing traditional stuff such as shares or equity, trading volume refers to the number of shares that have been traded. In crypto, it's actually the product of the volume of the price and the quantity. So to do that, there's a special situation. We've created a new data set here for you down here. I'm going to have to minimize this because first we've done is import NumPy as MP, just like we imported pandas as PD. And we've created a little table called trades. It's got price and quantity. Then we've got quotes. So this quotes here, there are just certain bid and ask values here, which we'll cover next week. Bids are basically prices that people want to pay for, asks are prices that people want to sell for. So you always have a discrepancy. And what happens is we merge these tables together, as you just saw. So the bid and the ask. So notice Dogecoin didn't have a bid and ask, so we assume no one was buying or selling. And what we've done here, I should be able to do this now without anything going wrong. If I do, what I do is I set a new column called df volume, and I say, it's already happened rather, it would be counterproductive. But essentially, if I can create a new column called volume, and I can say it's the product of price and quantity, and that volume column is here on the far right. To show you that visually, this is the table. The price and the quantity, we've just separated it, and each of those two numbers are multiplied. And then, so 24,050 cents multiplied by 75 gives you that result, so on and so forth. So we multiply each value in each row and get that result. This is done through something called vectorization. So a vector is essentially just a collection of numbers. It makes things a bit quicker, especially in the way that it was programmed. So you don't have to do loops, as you mentioned earlier. This is how Pandas does it. It stores these two numbers very close together and just asks them to be multiplied instead of looping through them. We can also remove a column that we no longer need. That's quite useful. We use something called the drop function. So in this case, what we've done is we've looked at the data frame. Maybe we don't want to look at the volume column anymore. So all we've done is we've just said, hey, can you drop the volume column? The volume column no longer exists. Also pass it to, you can also just pass volume without writing the column stuff here. The only thing you need to do is you need to specify the axis. Now I set axis just a moment ago. This is a visual representation. Axis 0 means that each of the rows are going to get added together, and that's what's shown here with the arrows. So all the numbers are going to get manipulated if they're on the same row. If we're doing axis 1, it works down the columns. So it's 0 to the left, from the left to the right, axis 1 from top to bottom. And it confirms the direction of data deletion in this case. So 0 means across the columns, 1 means down the columns. This is very across a row, sorry, 1 means down the columns. This is fundamental in a lot of data science as well, especially in other packages such as R, which some of you will tend to use. It's the same, relatively speaking, the same concept. We did have not a number values. Very simple. All we do is we get data Panda's replace function. I think hopefully if I just show you that here, yep, line it up. all we asked Panda to do is, hey, can you replace the not a number, because that's NumPy's, it belongs to NumPy, and NumPy invented it, and say, can you replace this with 0.1? So if we know the exact location, so this would be quite unlikely, but if we did know the exact precise location, so 25 columns down, 10 rows down, we can actually supply those coordinates. So in this case, I've said 2 rows down and on the bid column. What happens is that this row here, 3 rows down on the second index, and then just replace not a number with 10. Obviously, it shows just 10, but I've highlighted that it used to exist as not a number, but then it gets replaced to 10. To show you that it does work, just play that for you. So 0.1, so where it was NaN here, we've just replaced it with 0.1. Missing data is also usually represented by not a number, as I said, but we can also fill it throughout with fill NA, which is quite convenient. As I said, a lot of functions are convenient for their repetitive use. So we can fill it with 0, if I wanted to do that. Not sure if I can actually do it because I've already filled it in, but you can fill it with 0, you can fill it with missing, not sure where you would do that. You can even limit how many not a number values you want, so sometimes you might just want the first 10. Here I've just done 1, but you get the concept. But yeah, there's very many different types of combinations of work that I can do. There are other ways, so we can also estimate. Rather than just saying hard coding this value to be 0.1 or missing, we can actually interpolate. So there's a couple of different ways. First thing we can do is we can look at the row above it, or we can look at the row after it. So in this case, with not a number, there are a selection of 2 different things I could do. On a backfill, I look 1 row above, it has to be the same ticker of in this situation, and I'll say, look, can you find me the same ticker and just push in 24,050, which is assuming that that was the right number before the error happened. Or we can just look forwards. We might just want to use 51.97. If I just show that here, I think in this case, so you have the index here. So as I showed you, we can fill in the NAs as 0. Obviously that hasn't happened, but that would be the case. We can also fill in, obviously this is just repeating the same thing. Fortunately, that is an error on my part, but yeah, we have backfill and forward fill to compensate for that. The trouble is when you do PowerPoints, you're always starting on the same raw code, but as you do notebooks, it depends on the code above, so it propagates the solutions downwards. Pandas also has interpolate, as I mentioned. So what happens in interpolate, it's a bit more unique. So we have something called limit direction, so which direction to go to in terms of filling in that value. So rather than actually copying the value above or below, what we tend to do is we tend to go right in the middle. So between 25 and 35, there's 30, and all I would do is fill that in with 30. And both tells the program to go above and below. So both going above and below the cell. I don't think I have that anymore because teaching with notebooks is a very different story. But if it was the case, I would be able to. Let's see. I don't know if it works actually, but hoping it doesn't break. Unfortunately not, but that would be how it works. Actually, here it does. Rather, it does. I think it does it for this one here. So it does 24,000 here. That would be the situation with interpolate. So it takes the records above and below. We can also delete rows if there are any NA values. So if we have a, this is more of the case. So you can see that this row has not a number. We don't want this row. It's an invalid row. All we do is delete it. To do that, we just do drop NA. It says drop any rows with NA in them. In this case, we're not dropping the rows, we're dropping the columns. How do we drop the rows? So drop all the rows all the rows only if they have missing values, or any rows if they have any missing values. So in this situation, all the values have to be NA from left to right for it to be deleted. But in this one, if only one of those values is NA going from left to right, any one of those columns has an NA, that row is automatically deleted. Sometimes it gets more interesting. So, all right. Sometimes we might want to combine some data. This is also known as aggregation. So aggregate means take small stuff and put them together. It's very useful, for example, when you have a database. So we have different types of functions that we might want to different quantities we might want to calculate. We've got mean, sum, count, min and max, and aggregate. So data frame mean is when we calculate the mean, and we only want numeric mean. We don't want to take the mean of letters, for example. That shouldn't exist. Sum is basically when we add up all the numbers together down the columns. That's hence axis 1. Or all the rows rather, but we're going down the column. That's what it means. Count is basically just, well, count would just be to count the rows, but in this example that I've shown you is to take the mean of just a bid column. Aggregate is a special function. It allows us to use any number of these at any one time. So I can ask the price, bid and ask to aggregate themselves to give me the means, count and sum respectively. So if we look at this example, the mean of the price, quantity, bid and ask are all these values. They've just been presented as such. But if I ask the bid, the bid column to store the value of its mean value, so I first calculate the mean of the bid column, and then I just replace that value throughout the column here. So it's £12,626.24, as you saw here. You wouldn't normally do that, but it's just here as an example to show how that saving happens. So likewise with aggregate, you take these three columns here, price, bid and ask, and you just ask it for its mean, count and sum. Same thing there. The way this is done normally in larger data sets is we do something called split, apply, combine. We might have different rows that correspond to different coins. So what we do is we split it. So we split it into Bitcoin, Ethereum and Solana. Then what we do is we apply something. In this case, we're applying a sum. So get across to that. So it's 10 plus 9 is 19. 7 plus 2 plus 5 is 14. 10 plus 6 is 16. Then we combine them. Just replay that. We combine them. So they all come back together in one unique form. So, in practice, what we do is we first group all our data, as you saw. So we group the data by ticker and price. We can group by multiple columns, as you see here, or we can build our own aggregation function if you want. So in this case, as you'll see, if I just do this as a test, all the tickers will have the number 2 applied to them. That's a very rare case. So here what we've got is first this is me resetting the data table. So I'm merging it together using the time and arranging it by ticker. Then I'm setting the index. So I want to be indexed by year and time. You'll see later how to remove this time and hours because we normally don't need that. Then we group it by the ticker and then we sum them together. So group it and then sum it, as you can see here. If I want, for example, mean, I just have to change that. That should work. There you go. So you have these are the means. The other ones, I can't remember off the top of my head. If I want the minimum, might be quite useful to see where it was the lowest price. So the means, for example, were here. So the min of price was that much for Bitcoin, for Doge, for Solana, minimum quantity, etc., etc. But I'll leave it at mean to highlight the point. And also I can do it for multiple columns. So Bitcoin, I can look at its 3 different prices grouped together and look at its quantity. Doge, it's only got 1 price for the whole day in this example, and Solana as well. And this tells me the total quantity, total bid, total ask, so the accumulated sum. And if I want to also just apply a special function to show how this works, so I might want to group the tickers, BTC, Doge and Solana, and all I do is I apply the test. But there'll be other functions as well, for example, moving average, or for example, calculate a special mean or an unbiased mean, or a standard deviation with n-1 on the bottom to account for any bias, but especially if I want to do something myself. We're nearing towards the end. We've got another 14 minutes, so we're going to finish on time. We might also have time series, so we have to work with data that is arranged by time. Here's a very simple example. So this is time that's in days, month and year, because we're not American. So that's how we do it in the real world. So we're going to put a series together, and then what we're going to do is we're going to convert those years from strings into a special type of data structure called date time, which is how the computer stores it. I'm going to actually explain this because this is a common point of difficulty. If you look at Excel, Excel does not store dates the way you think it does. It actually stores dates as raw numbers. But basically, is I think it's in this case, for example, the number of minutes since 1970 or number of minutes since 1900. Because it can't store 24th of the 3rd of 2022. However, if I convert it to short date, I believe, and then just do HOI, well, that doesn't work in this case. But if I try 24/04/23, that's the date. But if I do general, that's how it shows. That's how it's saved in the computer. It's saved as 45,040. That's just a number of days, I believe, since 1900. In raw form. Some pizza as well. We'll just finish very quickly and then you can have your pizza. But yeah, that's how essentially it's done. But Python accounts for that as well. So that's how it's saved in Python. Specifically, the NS refers to nanosecond. I did say it's the precision, but I believe it's the number of nanoseconds that have happened since when it started measuring time between 1970 to now or 1900s to now. But it has lots of different memory to be able to calculate that. Just to point that out. So this is how it saves the data in date time. At the same time as well, you can have other options. So you might also want to change your time zone, say dt.datetime.time zone convert. So we might convert from, say, time that was recorded in American time to the time it was in the UK. For example, if it was trading in the daytime in the US, but we want to convert it into European time to see what that would have been in our time. You will also deal with Unix timestamps. This is the earliest. This is the special case in the computer where it starts from 1970. This example here highlights that. So we've got timestamps that are measured in that way, and we just convert it to date time. Just pass around the pizza while we're finishing. So that's how it's done in this example. And it converts the dates into, well, first it converts it into nanoseconds. It just stores it as the date format that you're used to. But then if I want to get the specific date, it stores it as an object. And to actually make it work, we also import datetime from Python. We install it first, pip install datetime. I've imported it the wrong way, but that's because the code is written like so. And then all I'm doing is then extracting here, in this case, the time column, as you can see here. And then what I can also do is manipulate the data to format it into year, month, day. That's the semi-American form. So I ask the time column to take each of the values as a lambda that you saw in the previous lesson, and I take each year, each date, and formulate it as year, month, and day. And I can also do that by converting it from string to date time. That's what I did in the first one, and then back from date time to string if I want to print it. And this is what it means. So from string from time, or take the string to convert it into a time, is to pass it. But these examples are not used very often, but they're quite useful. Where they're used, actually, just before we carry on, is you might see that we've got these little percentage signs. They're known as character codes. So, for example, in Python, you might be aware, and I can do this in my own example, you might be aware that when you print something, so print hello world, it prints in its own line. But if I want to print on a new line, so I want world to be on a new line, I have to include a /n, and it helps print it on a new line. This is what we call a character code, because that /n doesn't actually get outputted. It's just used by the computer as a guide to print that data. We use the same in dates. So we might want to print in year, month, and day. We just give it a percentage sign. So year, that's a century. The month will padded, or the day that's padded. So we have all these codes here to show how to align that. The character codes, they're based on the C language, so that's where they come from. And padded basically means that if we have, for example, the 1st of January, we actually put a 0, 1 of it in front of it anyway, so that's 0, 1, and for example, 1 and and 12 for December. So 0, 1 and 12 have the same width. So it just adds that 0 instead of doing 1 and then 12 because that's misaligned. I think that might be covered here. Yep. So you can see here, it just takes each of the values in this table and then converts into year, month and day. And then what we can also do is instead of looking at every day, we can normally crunch the data on a per weekly, per monthly, per quarter or per annual basis. We start by resampling the data, so rearranging it in terms of months. So what you can see here, we've got, for example, the 18th of November. That's not very useful for me. So what I might do, I might resample it and relabel it as November. And what I do is I relabel it to the 31st of November, this October rather, sorry. 18th of October to the 31st of October, and I relabel it as the end of the month. To actually make use of this, what I then do is I sum it together. So I resampled it already, and then what happens is that this is now the month of October, but we've shifted it all towards the end of November, end of October, and then all the other years, months are arranged accordingly. If we want to keep the original index, which I'm not sure why you would, but if you're interested, you just use a transform instead of the sum. It just helps to maintain the index consistency. So as you can see here, if I resample and then sum, I only get 1 month. But if I resample and then use a transform instead, I keep these 5 rows as expected. That's what we're doing here. Resampling, and then we're just keeping the number of rows the same. Finally, the interesting part here is to how to plot data. It's all very good actually using data, but there's another way to actually plot it. So the way we plot it is we use the plot method. You've seen this when you've done PyLab or Matplotlib. All I'm doing, and I hopefully can do this, first what we do is we read the data here. So this is data I've read from an Excel file. Now that I've got 5 minutes to do so. So I've read it from an Excel file and I've asked for the transaction sheet. What I'm going to do is I'm going to push some line down. All I have to do is I have to ask the data frame, so NFT transaction, which is what I've saved it as, ask it to plot itself. I ask it to plot the year and I ask it to plot what column I want. It will work for a bit and then that's the plot that it generates. It's very simple, it's very straightforward. You might notice that there's some overlap in the year, in the dates. That is fixable. You just twist the labels around. That's a separate thing. Here, what they've done is, so I just look at this. Here, what we've done here is we've done the whole data set. The dates, as you saw with the serialization, like Excel did, it saves it as raw numbers. So that's why it's 1.6 billion or something. That's 1.6 times 10 to the power of 9. But we can fix that in a moment. But generally, the concept is there. The first parameter is the x-axis. The second is the y-axis. You probably have seen this before when you've done your labs. We have 2 different things. We have something called arguments and keyword arguments. This is very important in Python. Keyword arguments require a keyword. So, for example, when we had on or column, that was a keyword, then equals, then the value that we gave it. That's a keyword argument. So here, for example, we've got transactions rolling. This is known as a moving average. I'm not sure if we actually, I think we are going to talk about moving averages momentarily, or maybe not today, or we are actually. So what happens here is that the first number here, the 30, doesn't have a word in front of it, so it's otherwise known as an argument, or a positional argument rather, because it's positioned right in front of the first bracket. The date, the on keyword rather, has the value of date. That's a keyword argument because I've given it a keyword as part of the Python documentation. Keyword arguments always go after positional arguments. So you always do all these numbers and letters without a word in front of them first before you do any keyword arguments. That's just how Python works. To show you that here, so here where I've done, well, you see it next, I've done the rolling average, which I'll discuss in a moment, but here I've used a keyword argument, and here I've used a keyword argument here and positional argument here. And hopefully if the hover reappears, which it does not, but when you were looking at the Pandas read CSV, you'll see this as well. So this was a positional argument. I just put in a address, but then all the keyword arguments come afterwards. This isn't really the best example, but other ones might be a lot nicer. So here, for example, I give it the path, that's compulsory, but then these are all optional, and these are quads, keyword arguments, K for key, W for word. Different people have different ways of saying it. Positional arguments, as I said, always come before keyword arguments. We don't have any, not sure what happened to the Amazon codes, but we'll post that in a couple of moments. There's a way of smoothing out this rolling. If you look at this graph, it's very spiky. That's not indicative of how trends tend to form, because sometimes you might have a very good day and then it will come back to the average. So to show that, we use something called a moving average. We smoothen out the plot. We're going to, what we tend to do is we tend to do a moving average. So we tend to take the last 30 days and take the mean. So take the last 30 days, we use rolling. So the last 30 days, last 30 records rather, and we look at the date column. So we're just looking at the 30 days, and then we take the mean of them. What happens is, if you look at this table as an extract, we take the first 3. In this case, we're doing 3. Obviously, 30 would be a 30 deep box. 70 plus 60 plus 110, which I believe is 330, divided by 3 is 110. We do that again for the next 3. That will give you 113. That's rounded, and then 100. And this is a moving average window of 3, where you think about it, if you have a window and you're just shifting that window along, that's a rolling window or a moving average window. Same thing here, just going downwards instead. But it happens a lot in graphs as well. If I think about it, if I show the graphs, if you have a little box here and then just moves to the right and then spits out a data point, same thing here. And that essentially smoothens out the graph, and it gives you a much better representation of what happened. So we had one very big spike here because there was lots of spikes, but on the other days it wasn't so much on a 30-day moving average. So the axes here, unfortunately, are not the same, because we've got 450 to 400, 0 to 2000, and also the dates are still not done in the correct format. So if we show you that here, so that's essentially the moving average here, the rolling, and we've just said, can you just look at the art blocks NFT, and that's where it produces. We can also do this situation here, which isn't very convenient, but we've shown it here, is if we're doing 1 day, 5 day, 10 day, 20 day, 50 day, and 100 day moving averages, and we're just looping through them with a for loop. So for each of these values, plot the 1 day, plot the 5 day, plot the 10 day, plot the 20 day, plot the 50 day, plot the 100 day moving average. This is the 1 day, this is the 2 day, 5 day, 1 day, 5 day, 10 day, 20 day, 50 day, and 100 day on the bottom there. That's not very efficient. We might want these all to overlap on the same graph. So what we can then do is we can then take this a bit further. What we do here is we use matplotlib and we ask it to give us a canvas here. That's what we've done. So plot.subplot. So to give us a canvas that's 10 wide and 5 deep. And then essentially, this is what it produces for us. It gives us a little canvas, and here is the labels of what each of the respective positions mean. And we want to plot all the graphs on the same axis, so we can actually get an overlapped graph like that. The legend here, again, is not informative because that's just the same graph. That's the same keyword thrown 6 times. We might want to use the label property. So what we've done here is we're using f strings to do this, and it will show us what we want to see. So to show that a bit better, now that I'm just wrapping up, if I get my other graph, f strings are quite cool in the sense that if I have, for example, for I in range 0 to 4 or 3 plus 1, you know that already it prints I. That's not very that useful. I can actually do f. What I can do is my string is plus I. It won't let me do that. I'd have to do string and then convert the number into a string. Also, this is not very efficient. So what I can actually do is I can just do print. I put an F in front of the string to say that this is going to be formatted, i.e. we're going to put other date, we're going to put something else inside it that's outside of that string, and then print I. My string is 0, my string is 1, my string is 6. Much cleaner, much quicker. We're doing the same thing here. So we put 1, then we put 5, then we put 10, 20, 50 and 100. So when we plot it, you can see 1, 5, 10, 20, 50 and 100 being printed out. You can have a look at the Jupyter Notebook. And there is also the same code. There is code also that plots the same figure but on different axes that Imran's provided. And finally, we're nearly there. You can also plot multiple different graphs by passing a list for the y-axis. So we can print 3 different graphs. As you can see here, it's not very different to what you've just seen. And we can also get other types of graphs. So for example, bar charts, stacked bar charts. So all we have to do is have to say, what kind of chart do I want? I want a bar. Do I want it to be stacked? Yes. And it gives me this. It's not very, you can't see all of this because it's a very big data set. So what I can then do is I can make this easier with either 2 ways. I can just choose the last 30 data points by using tail and making this figure, this size of this canvas a lot bigger. Or I can just reformat the dates so it doesn't look like very big numbers. What we've done here is we've gone for option A. We've just taken the last 30 data points and plotted it like that, and it looks very cool. Gives you a much more representative example. So it's the last 30 data points in 2022. I believe that's the last thing. I'll just show you that as well here, because I know we're all hungry. So working through the same thing. So you can see that we've got 3 different graphs being plotted. We still want to fix the dates. We've plotted the whole data set, so it gets very messy on the x-axis. So what we've done is we've reformatted it. So we've taken that raw number, turned it into a date, and then just formatted it into year, month, and day. And then got the stacked bar. And that's it, really. I do apologize. There wasn't as much writing code in this one as I could because there was so much code. But hopefully you've got a brief appreciation of how to do things. Imran's left a book here to suggest. So it's Effective Pandas by Matt Harrison. I've never read it. I'm sure it's very good. Stuff that we haven't covered, such as time manipulation, statistical analysis, regex, which is just using strings, and plotting, so advanced plotting. But we'll cover that probably another time. I'm very hungry for pizza, and so thank you very much. And hopefully, if you want to come back next week, come along. I will probably flash up all the Amazon codes very shortly now, so you can all compete in a rumble for it. But thank you very much, and I hope you have a good time. Yes. Slides are in the Google Drive, so if you go to slide 5, there you go. They're all here, hopefully, which they should be in a moment. But thank you very much. Right, for some reason I didn't have the code, so what we're going to do, we're going to switch off the desk for computer for a second. I'm